Jackson cross cylinder, very difficult to understand as a student and very difficult to perform as an optometrist, right? No. Let's learn Jackson cross cylinder in just few minutes. Jackson cross cylinder used to rule out the astigmatic power and astigmatic axis of a cylinder, right? And remember one thing in Jackson cross cylinder, we have three different components of this Jackson cross cylinder. Number one, this is called the handle of the Jackson cross cylinder, right? And we have one red line, which is axis of the minus cylinder, and we have black line, which is the axis of the plus cylinder. So the first step in Jackson cross cylinder is called the bracketing, right? In which we rule out the proper axis of a cylinder, right? So for example, we have already established the best VN sphere. And for example, assume that -3 is our best VN sphere right now, right? And after that, we will put the Jackson cross cylinder handle at 90 degree. Remember one thing about Jackson cross cylinder, when you will put the Jackson cross cylinder's handle at 90 degree or 180 degree, the lines, which is a red line and the black line, these oblique lines will go at oblique axis, right? At 45 degree and 135 axis, right? And if I put the Jackson cross cylinder handle at 45 degree or 135 degree at oblique axis, then these red and black lines will go at horizontal and vertical meridians, right? So the best VN sphere, which is -3, is placed before the patient side. And now I will put Jackson cross cylinder's handle at 90 degree, as you can see. So right now the handle is at 90 degree. So now the red and the black line at 45 degree and 135 degree, right? And this is called position number 1. And I will ask the patient, is there any improvement or not? If patient rejected this position number 1, then I will simply flip the Jackson cross cylinders at the same axis when the handle again at 90 degree. But now the red and the black line are replaced, right? And now this is called the position number 2. And I will ask the patient, is there any improvement or not? For example, patient refused, right? He said that there is no any improvement at this position, right? So patient refused or patient rejected both of the position number 1 and position number 2, right? At position number 1, for example, minus cylinder is at 45 degree, patient rejected. At position number 2, after flipping, patient rejected the minus cylinder at 135 axis as well. And now I will go to check another axis, right? So I simply move the handle of the Jackson cross cylinder at 45 degree, right? And you know, when I will put Jackson cross cylinder's handle at 45 degree or 135 degree, the black and the red axis lines of the cylinders will come at 90 degree and 180 degree, right? And this is called the position number 3, right? And at position number 3, I will ask again the same question, either there is any improvement or not. And for example, patient refused and rejected. So I will simply flip the Jackson cross cylinder at the same axis, right? And I will place the handle at 45 degree again. And now the red and the black line replaced, right? So this is the position number 4. And I will ask the patient, is there any improvement or not? So for example, patient accepted the position number 4 when the minus cylinder was at 180 degree, as you can see here, right? So this 180 degree are my axis. And after that, I will remove the Jackson cross cylinder. So the power of the Jackson cross cylinder was 0.5 cylinder, right? So I will put the same powered cylinder from the trial box, and I will place this cylinder, which is called a trial cylinder, at the same axis which patient accepted. And your accurate axis must be in the range of 180 degree, like 180 plus minus 20 degree in either side. So now we have ruled out the proper axis of the cylinder, right? And now the turn is of the proper power of the cylindrical lens, right? So I will keep the Jackson cross cylinders again in my hand. And right now, for example, we assume that patient accepted 180 degree as the purest axis or accurate axis. So right now my trial cylinder is at 180 degree. So I will put the red line at 180 degree, same exactly, right? Like this. So both the trial cylinder and the Jackson cross cylinder axis are the same. So right now, both the minus lines, the trial cylinder as well as the Jackson cross cylinders, these two minus lines are superimposed, right? So the power is double. So if patient show, right, acceptance, or there is improvement in the visual acuity of the patient, then we will increase the power. So this is 0.5. So I will increase the power. I will make the power double. So I will make it 1, -1, right? And again, I will do the same thing. I will align both the axes, right? The axis of the Jackson cross cylinder, the red line, and the axis of the trial cylinder, right? And if patient accepted, I will again make the power double, right? I will increase the power until the patient got the maximum visual acuity. So the last step is called the rule of thumb in Jackson cross cylinder. And how we will perform the rule of thumb, remember, our prescription was the spherical was -3 spherical. The cylinder was assumed the total cylinder is 1.5 right now, right? So axes are 180 degree, which are accepted by the patient, right? And total cylinder is 1.5, which is accepted by the patient. So now we will apply the rule of thumb. How? The total cylinder is -1.5 cylinder, right? And after that, we'll make a half of this cylinder. So the half of the 1.5 cylinder is 0.75, right? So we will add -0.75 into the spherical, which is -3, right? And when we will add this 0.75 with the opposite sign, remember, with the opposite sign. So -0.75 was half of the cylinder. We changed the sign, and that will be +0.75. And now this +0.75 will be added in the -3 spherical. So the resultant prescription will be -2.25 spherical with -1.5 cylinder at 180 degree.